Hi class, today we're going to be looking at some more patterns. It's always patterns with this chapter, right? And we're going to be looking at this sheet called triangular numbers, so go ahead and take that out, okay? All right, so we're going to go ahead and begin by looking at these figures here. You can see when it comes to figure 1, you've got 1, 2, 3, 4, 5, 6 black dots, or rather, what you can see this as is 1 plus 2 plus 3, if you kind of imagine it that way. And that's what you see here, 1 plus 2 plus 3. Okay? In figure 2, what we're doing is we're saying, let's say we know 1 plus 2 plus 3, and we're going to then do the opposite, which is instead of having black dots, now have white dots, and we're going to say 1 plus 2 plus 3. And in that respect, notice how what you have is like a 2 times 1 plus 2 plus 3. Okay? Let's go ahead and draw similar figures for A, B, and C here. It says 2 times 1 plus 2. So what that means is we want 1 plus 2. But then because we have 2 of them, we're going to need the white dots as well. So 1 plus 2, like that. Okay? In part B, we see 1 plus 2 plus 3 plus 4. So we do the black dots first, or purple dots here. 1 plus 2 plus 3 plus 4. And then we need double that, so we're going to do the white dots now. 1 plus 2 plus 3 plus 4. Okay, and if I did that symmetrically, you can kind of see it does form that rectangle. Similarly, for C, we have 1 plus 2 plus 3 plus 4 plus 5. And we have double that, so we're going to do 1 white dot. Remember, it's kind of going in reverse order, so it's going bottom to top now. 1 plus 2 plus 3 plus 4 plus 5. Now notice every time I do this, everything does line up just the way it should. You know, you have all these columns right here, right? Everything lines up perfectly. And you can see the black dots line up with the white dots just the way we want, kind of like that. Okay? All right, so let's take a look at problem number 2. The number of dots, both black and white, in figure 2 is 3 times 4, which is the same as 3 times 3 plus 1. Why is it helpful to think of 4 as 3 plus 1? Okay, so go ahead and think about that as you look at the diagrams up above, figure 1 and figure 2. You know, what we see here is a 3 times 4. What we see is that this is basically 3 times 4. And what this is asking us is, why is this 3 times 4 thought of as 3 times 3 plus 1? Well, we know 3 plus 1 actually does give us 4. But why do we change the 4 into 3 plus 1? Hopefully what you're seeing is that the 4 is made up of the 3 black dots along with the 1 white dot, like that. So it's 3 plus 1 there, okay? So why is it helpful to think of it like that? That way we can actually compare the black dots versus the white dots, right? We have the 3 black dots and 1 white dot, okay? So you have 3 from the original black dots, and you add 1 white dot to the row. That's how we get that 3 plus 1. Okay? All right, figure 2. We have 2 times 1 plus 2 plus 3. Where does that come from again? 2 times 1 plus 2 plus 3 equals 3 times 3 plus 1. As we look at our diagram, where are we getting this phrase? 2 times 1 plus 2 plus 3 equals 3 times 3 plus 1. It's going to require you to look back at this picture here. 2 times 1 plus 2 plus 3. Think about what that means. 1 plus 2 plus 3 is the part that makes up this shape here. The 1 plus 2 plus 3 is giving you this shape here. Hopefully what you're seeing is that 1 plus 2 plus 3 is actually forming the shape of a triangle. You know, if you look at the white dots, it does the same thing. You have 1 plus 2 plus 3, giving you another triangle. So in a way, what this is saying is 2 times 1 plus 2 plus 3, that's basically saying that you have 2 triangles, right? More specifically, it is the area of 2 triangles, right? Because 1 plus 2 plus 3 is giving you these, the shape of a triangle. You have 2 of them, you get the area of 2 triangles. Well, when you join 2 triangles together, think about how you can form triangles together. When you join 2 triangles together and they click in together, you know what you're going to form. You end up getting a rectangle. Well, if the area of 2 triangles forms to give you the area of 1 rectangle, right, then we can see that the area of a rectangle is formed by base times height. And what's our base and height? Our height is 3, and our base is the 4. That's where this comes into play. Our height was 3. This is the area of a rectangle, which is the height, which is 3, times the base, and the base is made up of 3 black dots and 1 white dot. So the base is 3 plus 1. Okay? So what we have is the area of 2 triangles equals the area of 1 rectangle. And with that formula in place, now what we can do is just a little bit of algebraic manipulation. What we want is actually to leave 1 plus 2 plus 3 all alone. By doing that, you can see that this 2 needs to move over to the other side. So we divide both sides by 2, and here 1 plus 2 plus 3 is the same as 3 times 3 plus 1, the area of a rectangle, divided by 2. This is basically saying, another way of saying that the area of one triangle is equal to half the area of a rectangle, right? That's basically what this statement is saying. Okay, so we're going to use that same kind of formula in doing A, B, and C. Let's take a look at A first of all. Okay, now in A, what we had was, notice here, based on this diagram that we have, we want to form 2 triangles, and our triangles are going to be the black triangles and the white triangles, like that. So you can see that the area of a triangle is 1 plus 2, and we have 2 of them. So what we're saying is 2 1 plus 2's give us, so that right now this is the area of 2 triangles, give us the area of the entire rectangle. The entire rectangle is made up of 2 times 2 plus 1, the 2 black dots, plus 1 white dot. So this is the same as 2 times 2 black dots plus 1 white dot, like that. Okay, and so recall this means 2 triangles is the same as 1 rectangle. And from there, when we want to just solve for 1 triangle, because all we want to really find is what 1 plus 2 is the same as, then what we can do is divide both sides by 2 to get that 1 triangle. So what we're saying is 1 plus 2 is the same as 2 times 2 plus 1 all over 2. Okay, like that. Let's do B. We're not really simplifying anything here. We're just going to leave it as is. Okay, so for part B, let's see what we have in our diagram. Remember, we want to compare black dots versus white dots. In our black dots, we see that we actually end up with that triangle there, which is made up of 1 plus 2 plus 3 plus 4. Okay, so we say that we have 2 triangles, 2 of the 1 plus 2 plus 3 plus 4. Okay, that is 2 triangles. 2 triangles makes up 1 rectangle. What's that rectangle? It is 4 times 4 black dots plus 1 more white dot. So 4 times 4 plus 1. So on over here, we're going to write 4 times 4 plus 1. Keep in mind, this represents 2 triangles equals 1 area of a rectangle. From here, to solve for 1 triangle, we can divide both sides by 2. So 1 plus 2 plus 3 plus 4 is going to equal 4 times 4 plus 1 all over 2. Again, we're not going to simplify this. We just want to write the formulas here, okay? All right, let's go on to C. In C, we're going to compare two triangles. I'm going to erase these red lines here. Let's start all from scratch. Okay, there we go. All right, there we go. Okay, so we have two triangles. One is the black and one would be the white, correct? Okay, so we're going to go ahead and label this. Oops, I think I missed a dot there. All right, so we have 1 plus 2 plus 3 plus 4 plus 5. We have two of those triangles. So 2 times 1 plus 2 plus 3 plus 4 plus 5 is equal to the area of the rectangle, which is 5 times, what do we have here? 5 plus the one additional white dot. Okay, so we're going to say that's equal to 5 times 5 plus 1. Okay, and then from there we're going to divide both sides by 2 again. So what we say is that 1 plus 2 plus 3 plus 4 plus 5 is equal to 5 times 5 plus, 5 times 5 plus 1 all over 2. Okay, there we go. All right, so the goal here is to try and find a pattern among these three examples and to now try to relate it to saying, well, what happens when, in these cases I did 1 plus 2 or 1 plus 2 plus 3 plus 4 or 1 plus 2 plus 3 plus 4 plus 5. Now let's change it to 1 plus 2 plus 3 plus 4 plus 5 plus all the way to 100. Okay, so we could create dots out of this. Oh my goodness, that will get really crazy, huh? Actually, it does say that for us to do that. How can we use dots to convince someone what our answer is? Well, I don't know my answer right now, but what I could do is construct dots. Now, do I really want to draw all those 100 dots? Probably not. But what I could do is a diagram saying I'm going to start off with 1 plus 2 plus 3, right? And I keep going and going and going. I keep adding dots, 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 all the way until you know that by the end, by the 100th row, you'll end up with how many dots? Hopefully what you're saying is you're going to have 100 dots. So you have 4, 5, 6, and of course, I don't want you actually counting 100 dots, but yada, 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 you're going to get to 100 dots. What we have accounted for right there is 100 dots. Now keep in mind that those are all the dark dots, the black dots, okay? Oops, sorry. But remember that when we create a formula out of this, not only should we have black dots, we also want the white dots. So then from here, if there were 100 black dots, and the flip side, if there was one black dot here, then we want to have one white dot there. Then it goes up to 2 white dots. Then it goes up to 3 white dots, and so on, all the way until at the very top, the very first row, you should end up with how many white dots? Hopefully, what you're saying is there are 100 white dots up there as well. That way you create that symmetric pattern. And so when we end up creating a formula for this, what we're saying is, again, think about this in terms of triangles and rectangles. What we know is that we have two triangles, a dark side and a white side. Okay? And so what we have is two areas of triangles. The triangles' areas are made up of 1 plus 2 plus 3 plus yada, 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 all the way until 100 at the very last row. So we have two triangles of 1 plus 2 plus 3 all the way to 100 is equal to the area of one rectangle. What's the area of the rectangle? Well, let's look back at the dimensions. What's our dimensions here? We have a total of 100 dots. So it's 100 as the height, and the base is made up of 100 black dots plus 1 white dot. So it's 100 plus 1. So therefore, in solving for just 1 plus 2 plus 3 all the way to 100, what do? We divide everything by 2. So what we say is that 1 plus 2 plus 3 all the way to 100 is the same thing as 100 times 100 plus 1 divided by 2. Okay, and what is that? Let's think. 100 divided by 2 is 50, and 50 times 101. Wait, that sounds very familiar. We've done that before, right? That's going to give us a value of 5,050. Okay, so that's going to be our answer for 4A. Hopefully, you're starting to see that pattern emerge, and we're going to see that carry forward onto the next page. Now we're going to see a more general case. Okay, so in this more general case, what happens if you want to add 1 plus 2 plus 3 all the way to n? Now, it may not be 100. Maybe it's actually 50, right? Maybe n is 50. Or maybe n is 500. We don't know. We're just going to some random number. How are we going to do that? Again, we want to use dots to convince someone of our answer. And how can we do that? It's the same idea. What we can do is we say, we start off with 1 dot, then we go to 2 dots, then 3 dots, all the way to how many rows are you going to have? Hopefully you're saying, oh, I'm going to end up with n rows, right? So you're going to have n dots here. You're actually going to end up with an n number of black dots here as well, right? This is n number of dots here. Okay, and then you're going to repeat that procedure, but this time with the hollow ones, the white ones. So you're going to have 1 dot there, and then 2 dots, and then 3, all the way until you have n number of white dots at the very top. Okay, so keep in mind you're going to have that 1 there. So what does this look like? How are we going to find 1 plus 2 plus 3 all the way to n? Well, you have 2 triangles, and the triangles are 1 plus 2 plus 3 all the way to n, right? Okay, that's going to give you 2 triangles, areas, and you want to set those 2 triangles equal to 1 rectangle. What's the rectangle's dimensions? You have n rows, so that's your height, times, what's your base? It's n black dots plus 1 additional white dot, so n plus 1, okay? Like that. And then we want to solve for just 1 plus 2 plus 3 all the way to n, so cut everything in half. And so 1 plus 2 plus 3 all the way to n is n times n plus 1 over 2. Whoa, that formula kind of looks familiar, doesn't it? We've seen that formula before, right? We have seen that back when we did our sequence patterns. We saw that sequence of 1. Oh, look at this. We saw the sequence of 1 and then 3. When you add them up, 1 plus 2 gives you 3. And then the next one is 1 plus 2 plus 3 gives you a total of 6, right? We saw 1, 3, 6. That was the pattern we saw, right? 10, 15, and so on. This is basically giving us our formula, but now we're seeing that we're actually adding our numbers up. Okay, this is getting into the idea of how we can now go from sequences and find our way into adding those sequences up and giving us something called now a series. This is going to be our next topic very soon. Okay. Now, before we actually get into series, though, let's actually just take a look at a couple more examples here. See how that 1, 3, 6, 10 plays into this. Oh, right here, right? We see that we start off with 1 triangle, and then here we have 3 triangles. What we're going to do is build consecutive triangular numbers. And by doing that, just look at how these are all squares. So this was like 2 squared, right? And 2 squared was made up of 1 and 3. Over here, if we build more triangles out of this, what you can see is that you'll always have a smaller triangle along with a bigger triangle. So in a way, we can call this first triangle like triangle 1, and then here's triangle 2. See, triangle 2 has 3 dots. Triangle 2 is going to have 3 dots. But then we're going to get to triangle 3. That's going to be our next largest. And then over here, we're going to break this up into a smaller triangle and a larger triangle. Right, and notice how these are all squares. This is going to be a 4 by 4 now. Okay, this 4 by 4 has the triangle 3 here in place here. So this next one's going to be triangle 4. Okay. As we go on, we're going to break this up again. This one's going to be the same that we saw up above. 1, 2, 3, 4. This is going to be 1, 2, 3, 4. This is triangle 4. Here, this one will represent triangle 5. This is our next largest triangle. Okay, and over here, we'll do it again. We'll have triangle 5 right here, since it's made up of 1, 2, 3, 4, 5. And this one's going to be triangle 6, like that. Okay, T6. All right, so with those triangles in place, you can see here that we're going to call these consecutive triangular numbers, because when you add up these numbers, 1 plus 2 plus 3, that's actually giving you the formation of a triangle. Okay, and these triangles just go consecutively. So as we take a look now at the bottom, we're going to let T1 equal that dot of 1, the array of 1. T2 is the array of 1 plus 2, as we saw up above, right? 1 plus 2 is giving you T2. T3 is 1 plus 2 plus 3. Okay, so that's going to be T3, and so forth and so forth and so forth. Okay, so we see that those summations give us 1, 3, 6, 10 for T4, 1 plus 2 plus 3 plus 4. T sub 5 is 1 plus 2 plus 3 plus 4 plus 5, which gives us 15, right? We've seen those numbers before. Now what we're developing here is, you can see that if we want to find the squares, the sum of two t terms, then 2 squared is made up of, 2 squared is really just 2 squared, that's really just this square here, made up of t1 plus t2. So that's what we said here. It's t1 plus t2. So what's 3 squared made up of? We can take a look up above. 3 squared is made up of t2 plus t3. Okay, so we can just say that here. This is made up of t2 plus t3. Let's go to 4 squared. 4 squared is right here. It's made up of t3 plus t4. Okay, so we go here, t3 plus t4. 6 squared, or 6 squared? 6 squared is 1, 2, 3, 4, 5, 6. That's going to be D here. It's made up of T5 plus T6. Okay, so T5 plus T6. So hopefully you can start seeing a pattern here. T squared was T1 plus T2. 4 squared was T3 plus T4. 6 squared was T5 plus T6. What do you think 15 squared is going to be? Look at the pattern there. Hopefully what you're saying to yourself is, you always see that the 6 squared or the 4 squared is that second triangle. So it sounds like what we'll need is T sub 15. And we always want the one that came right before it, right? You always want the one that came right before it. So hopefully you're saying, oh, we need T sub 14 there. So T sub 14 plus T sub 15. Well, what happens when we need n squared? Then we're going to need T sub n. And what do we add to it? Hopefully you're saying, oh, it's the one previous. Look at that. We are creating our recursive function here. Okay, so the idea behind this is now we're in addition to creating the explicit formula, we can also create the recursive formula too. Okay, so that's all I want to share with you today in your video here. During our Zoom session, we'll be taking a look at a little bit more at this in more detail. Okay, all right. Have a good day, guys. Bye bye.